And now let's discuss the most interesting feature of structs, which is you can implement any kind of methods on structs, which is just like you can have classes in some other language, but in Rust you cannot have classes. So you just have a flexibility that you can define any kind of methods on like structs. Hey all, hope you will be good. I am very excited for this video because in this video we are going to discuss the most important topic in the Rust, which is called structs. Structs are the most important data structures of the Rust language. So let's jump to the video and discuss what these structs are and how to use these. So first of all, structs is the abbreviation of structures, and structures mean to like save different kind of values in a structured manner. So we have discussed already what this tuple was. Tuple was used to like group up and bundle up some of the values, but in a like some fashioned way. And you can access like if we take example here's this tuple, and if you want to access these values, you can access via using indexing, because all of the values in the tuples are indexed. If like this 2 value is on index 0, this on 1, and this on 2, so you can access these values. But what if I have to like access this hello, and I don't know where the hello is actually in the tuple? So I have to iterate over all of the tuple, and then I don't know because like where the hello is, so I have to iterate over all of the tuple and then I can find the hello. And this is like really a painful task related to resource consumption, because it will iterate all of the tuple, and we don't know like if there is like millions and millions of values in a single tuple, so CPU have to like consume in a intensive way. So here we go with the more structured way, like more structured data type in the Rust, which is structs. And what is struct in Rust? It is nothing, it is just like key value pairs in the Rust. So here you have indexing, but here how you can store values in Rust, it is just like simple. If you have let's suppose simple a user, what you can define is name of the user on the one side. This is the key of the data, and here you can store any kind of data at the value. And let's suppose you want to store the age, you can just write down the attribute of the data which you want to store, and you can just simply put the value of the data. So this is just key value storage in the Rust, and it is the most important and most efficient data structure. So how you can create this struct is, first of all, you just have to create a struct here named user. This is the keyword and this is the name of struct user, and then you just define what kind of values you want to store, like name, and then its data type string you can say, and then you can say age and its data type U64, and then here you can just simply put the values. Name is equal to anything, any kind of string, and age any kind of integer, you can say 25. So this is how you just define these structs. So now let's see at the code how some of the examples how structs behave in Rust when it comes to like borrowing and it comes to moving data. So let's have an example of different kind of things. So first of all, I have created this new project, like you can say new folder, using a simple command which is we have used extensively, like cargo new and then episode _4. So I will not run again as I already have. And now what you will have to do first is you have to create the struct, and first just type the keyword and then type the name of struct, and here you go. Copilot is helping us, and here we go. Like there are 4 fields here, and each of these fields have data types, and these are the keys of each of the data. So you can access each of the data via just pointing like we will see like how you can access these kind of values. And to access these values, complexity of accessing these values is bigger one, because you have strings and you just have to like username, you have to just point out the thing and you just access the things. So let's just create a new struct here. Let user1 is equal to name of the struct, and then you just put the values of each of the fields. And email can go user1@gmail.com, and then we go with the keyword sign in count, and then we go with the keyword active true. So this is just a like dummy data sign in count. We just count this number, how many times user sign in to any kind of platforms, and this is the active keyword here. So okay, so here we have the data, and here we are just storing out the values here. And if we want to print it out on the console, what you have to do is you just let's just print it out at the console and see what we get. So if we want to print this out, this will throw an error. So where we are getting this error is being got from this extension, Rust Analyzer, and I have installed it already. I have told you to install this thing, Rust Analyzer. So what the benefit of this extension is, like you don't have to so here's the extension. Yeah, so benefit of this extension is you don't have to like build the program again and again to check the even just compile time errors. So this extension gives you all of the errors whenever you are just typing and writing the program. So what the error this throwing is, user don't implement this display trait. So what you have to do to print this out, we have to implement some kind of trait here, which is implement trait for structs. So for this you have to implement the debug trait. And how you can just do this, like to implement this debug trait, let's put a comment so anyone seeing this can understand it properly. So you just have to implement this drive debug trait, and then you can just easily print this out. And to print this out now, what you have to do is just to have to put colon and then question mark, and we are not getting any error here now. So now just run cargo run, and you can get all of the fields input here, all of the fields output here in the terminal. So this is the trait, debug trait, which you have to just type out just before the syntax of the struct. So we will discuss out what this like traits. We have actually already discussed these copy trait and move trait, you remember, in the previous videos, but we will discuss in detail in the next episodes how these traits like became, and how these traits can be created, and yeah, all of the details about the traits. So now we are just printing this out. Let's suppose now we have to do what we have to build a user. So now let's build a new user. And how you can build this out is just creating a new function here. So let's suppose we have a new function build user, which is just accepting email and username from the caller line. What will be the caller line here? Caller line will be like that, and username 1, and what the email can be at gmail.com. It can be anything, and you just call this function here on this line, and we have passed these two strings from here. And the other data, from where the other data will came, it is just creating on its own. It is setting active to true and sign in count to 1. And what it is doing is return type is the user struct, and here we are returning this whole struct that we have created here in the function. Because you remember, if you don't put any kind of semicolon here, it means this method is just returning the last line. So this is being considered as last line, and it is being returned. So here it is being returned, and in the user2 we will have a new user. If we print this out, user2, we'll have this user in the terminal. Let's run the cargo run again, and we will have this user2 here. So this is how you can like create via some other method, writing some other function, and you can create any kind of other user. So okay, so let's take another example. So if you want to update the user, what you can do is just simply, let's suppose we want to update the user1, and we type user1, and then we type the name of the field. Let's suppose username, and we wrote ahead the updated username. So this is throwing an error, but this error is like we cannot mutate immutable variable. So what we have to do is we have to make this variable first mutable, and now it is being easily mutated. So this is how you can update the struct. Now let's see another example. We have another thing here which is called struct, tuple struct. And how you can create is just simply write the struct keyword and then name of the struct, and then you can have type of the struct kind of tuple. Like first we were creating it like having curly brackets and then a key and value pair. Now you can just only have these like tuple, and only you can have these values, and first you have to define data type of the values, and then you can just initialize this like using this. Let's suppose color is black, and you define the color via giving 0 0 0. So, and I think you are not getting this by creating this example. And now let's suppose if I have this rectangle struct here, and how many like arguments or values we can have for this is only 2, because we know rectangle have only height and width. So this first thing is pointing towards height, and the second value is pointing towards width. So this is how you can just create tuple struct, and you can take advantage of this at anywhere you feel like we have to use this kind of thing. So actually structs are used to just structure data, to give some kind of structured data, so your user can just have an idea like these fields are just bundled and used in a progressive manner and in a very defined manner. So let's see another example which is called moving values. We have already see this how moving and ownership works. So let's suppose create another user3, which is which have username from user1 dot username, and its email is also derived from user1, and all of the other data you can just define your own, or you can just have it like this. So this is how we created user3, and we stored the values in this user3 using the user1. So now let's suppose we try to access user3, which is totally fine. And if we try to print out user1 again, then what will happen? Let's suppose we are printing out the user1 dot username, and if we try to do this, Rust analyzer will throw an error which is borrow of moved value user1 dot username. Move occurs because user1 has type string. So remember, whatever the variable have type of string, this variable cannot be like moved first and then can use at later point. This can only moved, and this will not be able to, you will not be able to use this variable next. So where the move is happening here. So value moved here. What you did is user1 dot username, and now total ownership of the username is just moved to the this attribute of user3 variable. So now that's why this username is not being used anymore here. So but what if you do like you create its own variables via using string, and you create the email here via using a fresh string and creating a, okay, so if you did this, like creating a string from using string type, and then you just use sign in count from the user 1, this will not throw any kind of error if we use this sign in count here, because we know like all of the data types which are primitive, they implement the copy trait. Whenever you do this here on line 39, it is just copy the value of sign in count of user 1 to the sign in count of user 3. It is just duplicated the value of first variable and just like assigned to the sign in count of user 3, and it is not like borrowed or moved. So all of the primitive data types implement the copy trait, and we have discussed this in detail in our previous episodes. If you didn't watch it now, otherwise you will not be able to understand any of the next videos. So now let's see an example program using Rust, and I am just calling a method called example program here, example program, and I am defining it here, which is here. So now we don't need this copilot code, and we can create our own. We have a variable which is called height1, and we have another variable which is called width1. Now what we want to do is we want to calculate the area using these two variables, and for the area we have to have this area method here as well. Let's create another function which is called area, and calculating area using height and width, which is just multiplying values here, height and width, and returning the resultant of these two values, which is i32 type. So here you can just simply save, and if you run this program, what you will get is you will simply get the area of these two variables, which will be 50 multiplied by 30, which is just 1500 square pixels, which is being printed out on this line. So now if you see, this height one is a separate variable and this width one is a separate variable, which is not creating like too much sense. Like we don't know to which thing these variables are belong, and how these variables are being used in a very appropriate way. So to be more specific and appropriate, and to give a more good sense to any kind of any other reader, which can be more like helpful for readers, we can create a sum tuple here. And what we can do is, let's create a tuple which is called rect1, and it can have two variables, like this one is height and this one is width. And now if we try to calculate the area via tuple, what we can have is just to create another function here which is called area using tuple or area tuple, and which is accepting the tuple here. We are passing the tuple here. We have created the tuple here, rectangle 1, and now we are passing this tuple in this function. So this is being passed here and being accepted here in this function definition, in this function signature, which is dimensions. Like we have the name of the parameter, and then we just define the type of the tuple, like all of two variables. All of the two values here, 50 and 30, are of types i32, and then the second value is also of type i32. And what we are doing at return type is, it is also i32, which is being calculated after multiplying these two values of tuple. And of course, how we get values of the tuple is just via index of the tuple, because all of the values in the tuple have specific index. So just multiply these two values and we will have area of the tuple. So now if you see, this calculation is in a more concise way. This rectangle 1 here is containing these two values, and these are not like scattered, these are just at a specific point and conveying some meaning, like yes, we are doing some calculations on rectangle 1, and this variable rect1 is holding values and dimensions of rectangle. Now to be more specific, let's have an example using structs. So if we define struct here rect2 via using this rectangle struct, what will happen is, like, now we are conveying more precise meaning of these variables. Like, these two variables are associated with this rectangle variable, and wherever we will use this variable height and width, we know like these two variables are associated with the rect2 variables. So this is why we use structs to give and to deliver more precise meaning in the programming, so that everyone can know better and everyone can like perform different kind of operations on this variable struct in a efficient way. So for this, if we save, this will throw an error because we haven't defined any kind of struct named rectangle. So first we have to define this struct here. If we define struct here in a rectangle, it will have two fields, height and width, and both of these will be of i32. And to print the values out in the down, we have to have like define the debug trait here as well. So it is simple hash drive debug. So we can just have hash and then square bracket and then just type the name of trait, which is debug trait. So now just save it out and we are not getting any kind of error here. Okay, so this is just written down here. And now if we want to calculate the area, we have to create another function below, which is calculating the area now based on struct rectangle, not on tuple or any other kind of variables, but more specific towards the struct which is called rectangle. So this is accepting as a reference, but if you don't want to accept as a reference, you can do it and it is simply fine and it's not throwing error if I save this out. So now let's just run this cargo run, and you can see at the very below we are calculating the area of rectangle, which is 1500 square pixels via using this method area struct. So now you can see like this rectangle rect2 is delivering very precise meaning that these two variables are associated with this variable and are not any kind of random variables. And now let's discuss the most interesting feature of structs, which is you can implement any kind of methods on structs, which is just like you can have classes in some other language, but in Rust you cannot have classes. So you just have a flexibility that you can define any kind of methods on like structs. So let's have how you can do that. So let's suppose you don't want to have this area struct a function, like a separate function for the calculation of area on struct using structs. But what you can do, another magic here is you can just type the keyword implementation and then the name of the structs which you want to implement on, which is rectangle. And now you can have any kind of method here. And let's suppose we want to calculate the area on rectangle. So let's just delete these kind of methods for now and just keep this area here. Now what this dissect, now let's dissect this method. By the way, these are called methods, not functions. So any kind of function which is being defined and implemented on structs, we will call it method, not function. So now let's dissect it. So first of all, we have keyword function, like it is just same as of other functions but with a little bit exceptions. So this is here we have like function keyword just like other functions, fn keyword, then area. And now this is the interesting thing, every first argument in any implementation block, in this block implementation block, every first argument of any method, it will be self. And what this self is, self will always point toward the structure which is it's created on. So now as this method is being created on this struct which is called rectangle, that's why this self is being pointed towards this rectangle. So that's why you are just accessing these fields height and width via writing this self. So you just write self dot height and you are now easily accessing this height field, and you write self dot width and you are just easily accessing this width field. So this is what self is. Self just nothing, always just pointing toward the struct on which it is created on, and in this case this method is created on this rectangle struct. So this is the area method, which is just calculating the area of the using variables of this struct. So now let's try to access this method here, and instead of doing this, let's suppose you are just accessing area calculated is equal to rectangle rect1 dot area, and you just call this method. And what will happen here is, sorry, you cannot have one because this one variable is being on tuple. You can have two, and you just save this out and then just print it, and you can just have the area which is being calculated from here. You can just change the name area of rectangle via method on struct is this. So if you just save this out and run cargo run, you can have the area of rectangle via method on struct, which is the same as we calculated previously. So this is how interesting this is. So you can have any kind of methods that you want to here. If you want to have the method can hold, you can define this. So what this method can hold can do is, this will compare two structs and will say like the previous struct can hold the comparative struct or not. So this as usual, first argument is self and the second argument will also a struct, and this will compare both of the struct. First one, what the first struct will be, first struct will be the object which we will create, and the second one will be an other struct which is being accepted from here argument. Now let's see, so you can have a better picture. So let's suppose we are creating another struct rect3, and we are just implementing, let's suppose another struct struct4, and we can just compare these two structs, compare these two rectangles. And how you can compare is, just write down this method can hold, just create a variable can hold, and use this rect3 and call the method on this can hold, and pass this rect4 variable, this rectangle 4 in this method. And now rectangle 3 variable is being used as a self here. This self, as I already told, will always point toward this structure which is it's created on, and it is also it is like will always be also related to this instance, because we are calling this can hold method on this instance or this object, you can say rectangle 3. So that's why like this self method is now being pointing toward this rect3 variable here. So this rect3 variable have value of 40 and 10, and now of course we know these values 40 and 10 are less, and it cannot hold these bigger values. So what this can hold method will return, it will return the boolean. We are only comparing these values height this like rect3 height with the rectangle 4, and rectangle 3 width, rectangle 3 width with the rectangle 4, and we know these this comparison is just returning the boolean here, because this double ampersand is just evaluating this expression and generating a bool here, so which is being returned from here. So now if we call this method and then just print this out, and we can see this like, okay, if we run this out, what we can see is why this is not being printed out here. The area of rectangle method print can rect3. Okay, so this is not being printed here. Why? Okay, so it is here actually. There is no any kind of line break, so it is being printed out here. Can rect3 hold rect4, which is false. Of course, this have smaller values and it cannot hold any kind of bigger values. Like holding means we are just comparing, like these values are less than this, or these values are just bigger than the second rectangle. This is just the concept of can hold. So let make me another amendment to this self keyword is this self of course point towards this rectangle struct on which it is created, but this also, like this specifically, if I talk about in a more precise way, this always like reference or points towards the instance which is created via using this rectangle. Like we are, this rect3 is an instance, this rect3 is an object, like you are creating an object. So this so that self is being pointed towards this rect3 instance, or you can say just object. Let's say instance. So this self is just pointing towards this instance. So whenever this self will be used and you will call this method can hold, if you call this method can hold on this instance rect3, so this self will point towards this rect3. And if you didn't get it properly, let me have a better picture to you via our using our whiteboard. So let's suppose you have a rectangle here, struct which called a rectangle, and you have two fields here, and here's the implementation block which is just implementing the area method on the rectangle struct. So okay, so let's suppose you have a variable here which is called instance. You can call it instance, which is being created on this rectangle struct, and it has these two fields, height 3, width 4. So now let's suppose if we use this instance to call this area method. Now what you think this rect3 instance will be pointing towards? So this self is being pointed towards this rect3. Let me re-explain. If we call this area method on this rect3 variable, rect3 instance, what you think this self variable in this self argument, which is the first argument of this area method, now what you think this self variable will be pointing towards? This will be pointing towards this rect3, and that's why you can just call this self dot width here, and what you think this width variable will be, or this value of this width variable will be here. This will be 3, because this self is being pointed toward this rect3 instance, and this rect3 instance have value of width 4. Sorry, this will be 4. So if we have another example, like we create this another instance which is called rect4, and this is storing value height 5 and width 6. And if we call the method area on this rect5 instance, and what you think what this self will be pointing towards? This self will be pointing towards now this rect4. And now if we get or just like call this width, or we just try to get this width via this self variable, now what you think value of the variable will be? This width variable will be, it will be 6, because this rect4 variable have value of width 6 here. Let me just point out properly, this 6. So this width here will be having value of 6. So this self is always being pointing toward such instance which is calling the method of area. This self of area method will always be pointing towards such instance which will be calling this area method itself. Okay, so now let's have another example on our code editor, which is like you can have You can also have methods of associated like methods on the same name of these fields. Let's suppose I want to have a method which will be width. So what this width can do is, this width is called getter methods. If you have any method which have same name on the same name like the structs field have, like these fields have height and width, and if you have method which is also called width, this method will call the, also you can call getter methods of this struct. Okay, if you just and what this method is doing, just returning, like it's the getter, and what getter method do is it just return the value, current value of the struct. So it is just returning the width. So if we call this method out here, like let width of a rectangle 3, if you call this method, this will give you the width of this rectangle 3, which is 40 here. And if you call this width method on some other variable, like let's say width 2, and if you call this on rect 4, it will give you 60. Sorry, width is here 10, it will give you 10 in the case of rect 3, and it will give you 60 in the case of rect 4. So, and if you don't just call this out and you just leave the parentheses and you just save this, now this will also will give you width attribute of this rect 4. Like this is up to you if you want to create any kind of getter methods, and if you don't want to create any kind of getter methods. So in what case this can be helpful? This can be helpful if you want to hide this data of the rectangle, like you don't want to give access of these fields to somebody else. So what you can do is just create the getter method of width and say, hey, you can just have access to this width variable, and you cannot have any kind of access to any kind of other fields. So now let's take our example, the last example, which is associated functions, or you can say methods. And what these associated methods are just like constructors, as you can you have an idea already from other programming languages like C do it. These are just like constructor methods, and you can use these as to initialize the fields of these structs. And if I want to have, I can have any new method. Like this is the convention in Rust language. All of the constructors that you define are always have the name of new, but you can have any kind of other gibberish name if you want to have, but this is the convention which you have to follow, and it will be convenient. So this is the new method here, which is accepting these two parameters, height and width. And now what this returning is, which is interesting, this is returning the rectangle itself, which you can see here. So if I want to call this method here, let rect 5, and how this now how I am getting this rect 5 is just calling just by calling out this new method. And how you can call this method is just using double colon here. First name of the struct, then double colon, and then just call this method out via like passing these two parameters here. And this is called associated functions, and these are mostly helpful when you want to have any kind of constructors and you want to initialize your fields prior than any kind of other operations. So this is how you do with the associated function. And the other thing that I want to tell you is, which is like you can have any kind of like any number of implementation blocks on a single struct. Yes, you can have any number of implementation blocks on a single rectangle, and you can define any kind of other methods that you want to do. Like let's suppose if I want to have another method called height in this width is just defined in this implementation block, and I want to define height in this implementation block, I can easily do that. So you can like define many kind of implementation blocks on a single struct. So this is all with this video, and hope you enjoyed this video. If you did, just comment down, like and share, subscribe, and if you have any doubt, just comment down. I will try to resolve this out, and hopefully we'll make another video on this. So this is all with this video, and see you in the next episode. And just practice this out. I will push the code on the repo, and we'll leave the link in the description. So just check this out, and see you in the next episode. Bye bye.